Hello students, welcome to the next lecture on the CSIR UGC net. Today we will discuss all those questions from the year June 2023 related to the statistics here. We will describe all those questions from the part B. Myself Dr. Harish, you can simply follow my YouTube channel and you can scan and join my WhatsApp group for various discussion related to this CSIR as well as the GATE mathematics. Moreover, we also discuss the IIT JAMS paper for you related to this mathematics and statistics. So let's start with this question. So what I feel after seeing this question paper of this June 2023, the paper was very easy and you can easily solve it with the help of the conceptual things. For example, here, let x be the Poisson random variable with the mean of this. What is the meaning of that? Expected value of this is here, and we all know the variance of the Poisson distribution is same of the mean. Which of the following is not estimable? So what is the meaning of this estimable? It means if I say, it means your target is to find a function of this is my here, like this must be the function of x. If you are find this condition, then you can say this is my estimable, otherwise not. Like for the first case, what is the first part is you have to find a function of the x, so that answer becomes my here. For the second part, your target is to find a function of the x so that it becomes here. Third part will be here and fourth part will be here. Now how you can approach this? Remember always, I already explained you in the many videos, your approach is always to discard the options, not to find the correct answer. This is the question related to the part B, so the best way is you can discard them. Clearly says that this option is discarded. Why? Because you can see that here, this is the function of the x. You can see this is the function of the x. It means this is my estimable. Fine. This is my estimable, but we need a not. So this option is cancelled out. Look at the third option, x lambda square. Can you think about the lambda square from here? What is that? E of x square is nothing but my ex whole square plus variance of x. So what is that? This is nothing but lambda square plus of this. Fine. Now we need of this quantity. So how you can do that? This is nothing but my e of x. So I can take the combination of this x square minus x is my here. You can see this is the function of the x only, which is here. So it means this is also estimable. Fine. So this option is also cancelled out. Now think about the first and third. This part I can observe from the Poisson variable, but lambda inverse is not be there. So we can start from here. I need a function such that it becomes my here. So we all know how you can expand the function of this. So what is that? This is summation of any function into probability mass function. So if I write this quantity here, e of this lambda raised to power x over x factorial. So how you can think that it becomes my e raised to power minus lambda? How you can think that? Since this is after the calculation here, so firstly I can think about here. Fine. If I think about this function, you can see this is the function of this part will be cancelled. What is the remaining side? Which is nothing but e raised to power minus lambda. And you can see this is the function of the x only. This part is my constant. This part is my constant. This is the function of the x. So this part is also my estimable, but we need a not estimable. So the right answer is my here is the correct option. Another way, this is the first way. Another method is you can think also why the first option is the wrong option, because this is the mean. So if I say lambda is say in the centimeter, so this part is in my centimeter inverse. That is not be true, but this is not the correct way. The right way is you have to prove like of this manner. Look at the second question. Consider the random sample of these three elements 3, 6 and 9 which are observing from the normal distribution. Mean is my mu, which is unknown, variance is my 1. Then your target is to find the MLE. It's a very simple. What is that? It's a mean. Fine. So what is the MLE of the mean? This is my here. Fine. So we get as this is a sample. So what is the meaning of that? This is 3 plus 6 plus 9 over 3. That is my 6 is the estimator. But But you can see this answer is lies between minus infinity to plus 5. So first option is cancelled, fourth option is cancelled. So look at that. Your answer is 6, but this is not the right answer, which does not belong to here. Now which one is the right answer? Since you need a maximum of this, so what is the maximum value of this? As 5. So out of this, the maximum value is 5 is the right answer of this problem. So that's an interesting question. You get answer as a 6. 6 is also the answer, but which does not lies in this range. So it means your correct option is out of second and third. But we have to need the maximum value. So the maximum value of this is my 5 instead of the 3. Right answer is my B is the correct answer. Okay, look at this another one. What is given to you? Xi's are my normal distribution with the unknown parameter theta and 1. Suppose x bar, this is sum, and here this is my sample mean, and let t of 0.975 n minus 1 denotes, okay, I can written also this number as say alpha, student t distribution with n minus 1 degree of freedom. Okay, so it means this is my portion. Fine. So this is my rejection region, this is my reject H0, and this is my accept H0. What is the level of significance here? So look at that, 0.975 is my confidence interval. So what is the level of the significance? It's a 2.25%. That is a half of this. So it means this portion will be my 97.5%. That is called as the confidence interval. Now look at the answers. The interval is the confidence interval is exactly 0.95, which is not true. This is exactly 0.975. The interval of the confidence of theta is less than 0.95. This is not true, which is greater than of 0.95. So this option is also cancelled. Is more than 0.95 is the correct option. No confidence interval, cancel out, because there is a confidence interval. So the right answer is my third is the correct option. Okay, look at now, this is the interesting question. This is the bivariate distribution with a mean and here, and you have to find the mean and variance of this. It's very simple. I can consider this quantity as say y1. Second quantity I consider as 5 minus 2x2. Then your target is to find the mean. So what is the mean of the y1? Mean of the y2. This is my mean matrix. So what is the mean of the x1? 0. So this value will be 0. This answer will be 5 minus 0 is 5. So look at the options. All the options are correct. How you can find the covariance matrix? So that's again a very simple. That is a variance of y1, variance of y2, and this is my covariance of y1, y2, covariance of y1, y2. Now firstly we can find the variance of y1 is nothing but variance of x1. What is the variance of x1 is 5. Variance of x1 is 5. So this number is 5. What is the variance of y2? This is 0. This is 4 times variance of x2. What is the variance of x2? This is my variance of x2. So it's a 40. So 5 and 40. So second option cancel, third option cancel. Now look at the covariance. What is the covariance of y1, y2? We all know we can find as a y1, y2 minus ey1, ey2. Now clearly says what is the e of y1? 0, ey2 says, so this part is 0. What is that? What is the y1 into y2? It is 5x1 minus 2x1 x2. If I open this bracket, this part will be 0. So it is minus of 2 x1 x2. Now how you can find the e of x1 x2? We can use this covariance formula. What is the covariance of this? It is given as minus 3. So I can apply this as x1 x2 minus ex1 ex2. 0 is minus 3. So what is that? This is plus of 6. So this is 6, this is 6. This is the right answer. This is the wrong answer. Correct option is my fourth is the right answer. That's a very simple. There is no need to think about anything. Whatever the relation is given to you, consider as a y1, consider as a y2, find the mean, find this matrix. Variance of this, that is a diagonal entries. Covariance we can use here and you can get as the right answer. Okay, which of the following is a valid cumulative distribution function? Fine. So what is the property of the cumulative distribution function? First of all, it must be the continuous. Like, if what is the value of the f0 on the both side? Half, and in this case it is 2/3. So remember, whenever there is a continuous random variable, then these two values must be same, but they are not same, and it is not given that it is a continuous. So once they are not same, it means they are my discrete random variable. Now this, we can't say that about this problem. So what are the properties of that? We all know f of minus infinity will be 0 and f of plus infinity will be 1. Second is f is my increasing function always. So firstly, let me check f of minus infinity. Minus infinity here is a 0. It's a 0, it's a 0, it's a 0, satisfied. What is the f of infinity? Plus infinity. So it's a infinity by infinity. You can apply the L'Hopital rule. So 2x by 2 is a 1. It's satisfied. It is not satisfied. The L'Hopital rule is 2x by 4x. It goes to the 1 by 2, which is not equal to 1. So this option is cancelled out. Look at this option. You can take the L'Hopital rule. So minus 2 sin x plus 2x over 2x. So I can take 2 as a cancel. So it's a minus sin x plus x I can take as here. So if you take the limit, it will be my minus 1. It's a plus 1. It's a 0, which is not equal to 1. So this option is also cancelled out. This option is a 1. So out of the first and this property satisfied. Now you can think about the increasing. So take any value from less than of here. So I can take x is minus 1. So what is the answer of this is 1 by 3. Take any value from here. So say x is equal to 1. So it is 3 over 4. Is as minus 1 is less than. Is it true? Yes. We can check here. At x is equal to minus 1, it is 1 over 3. At x is equal to plus 1, it is my 2 over 5. Is it satisfied? Yes, this is also satisfied. So then what is the third property? How you can think about that, whether this is the right or wrong? So this is satisfied. Now you can check about the 0. What is that? This is half. 0 minus half. 0 plus is 1 by 4. You can see that this is not satisfied, because this is a value is not satisfied. So what is the meaning of that? This is option is also cancelled. Correct option is my A is the right answer. Remember, your always approach is to discard them, not to find the correct option. Okay, next one is it's a probability density functions. Again, it is not given to you whether it's a discrete or continuous. Then you can think about any of them. Which of the following is not a probability density? So what is, if I consider continuous random variable, we all know this value must be 1. That's the definition of the PDF. So, and second is this value must be greater than or equal to 0. So look at the first case. If I integrate this, can this value be here? So if I take y is equal to x plus 1, so limit becomes same. This is f of y dy, and this value is a PDF. It means this condition satisfied. This is 1. So this is my correct statement. This is the PDF. F of 2x into dx, so which is half. If I consider this as a y into dy, so what is that? This is 1 half, which is not equal to 1. So this is the false statement. Look at the third option. It's a 2 is outside. F of 2x minus 1 into dx. So if I consider this as a y, dy will be 2 into dx is a dy. So again this will be my 1. So this is my correct statement. Look at this portion. If I take x cube as a y, then 3x square dx is my dy. So the integration of this will be f of y dy, which is again 1. This option is also cancelled. Correct option is my only second is the correct answer. Okay, look at this one. A continuous random variable x follows a uniform distribution over here. So what is the probability density function? We all know if x follows this, remember this, then the PDF will be 1 over b minus a. So in this case it is 1 by 2. y is equal to x square. Which of the following is not true? Independent and uncorrelated. So firstly, remember, what is the meaning of the uncorrelated? Uncorrelated means you have to find the covariance. If it is a 0, then it is called as the uncorrelated. Now look at that. It's a very simple. What is the covariance? Is EXY minus EXEY. Fine. Now what is the mean of the x? We all know what is the mean of this is a plus b over 2. So it's a 0. So once this part will be 0, this part is a complete 0. What is the y? Y is my x square. It is a ex cube. So ex cube will be 0. Why? Because you can see x cube into fx over the domain plus 1 to minus 1. F of x is my half. So it is my x4 divided by 8 from minus 1 to plus 1 is my 0. So what is the meaning of that? It is uncorrelated. So x and y are uncorrelated. Now check whether they are independent. You can see that y is dependent on the x because y is equal to x square. So x and y are my dependent. So look at that. X is independent. That's a wrong statement. They are independent. That's a wrong statement. They are not independent but correlated, but we get uncorrelated. That's a wrong statement. Neither is here. So but we need a not true. So this is a correct statement. This is the 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 wrong statement. So basically this question is from the part C. If this is a more than one correct option, this is the question related to the part C. That is a 1, 2, 3 are the correct answer of this. Okay, now look at this another question which is related to the regression models and the estimator. Remember, first of all, I will tell you a simple shortcut tips for you. If you have say beta 0 plus beta 1 x plus epsilon such that this epsilon is my normally distributed with the mean is 0, variance is my positive quantity. Fine. If this condition holds, then you can find the estimator of the beta 1 cap is a very simple shortcut tips for you here. X minus x bar, y minus y bar divided by here. Fine. And how you can find the estimator of the beta cap? This is y bar minus beta 1 cap of x bar. X bar is my mean, y bar is the mean. Now look at that. In this case, this is sigma square, but we have a variance xi square also. So we will try to convert this equation into in this manner so that the epsilon has a mean 0. Mean is 0 is given. Variance is my sigma square. How you can do that? First of all, this is xi square. So if I divided this by xi, what will happen? This is my epsilon I divided by xi. So if I take the variance on both sides, what will happen? This variance of the constant quantity is 0. This is xi square variance of epsilon I, which is sigma square. Fine. So if I consider this number, also if I consider the mean of this, what is the mean of this? This is beta. Why? Because this the mean of this is my 0. Fine. Now look at the which of the following is the correct. We need an unbiased estimator. What is the meaning of the unbiased estimator? A is said to be unbiased estimator of B when you find the expected value of A, it come to be B. That's a simple rule of unbiased estimator. Now look at that. You have to find a parameter, something which is an unbiased estimator of beta. This is your target. Now you can see what you got, that expected value of yi divided by xi is the, so what is the meaning of that? Yi divided by xi, expected value of this is the unbiased estimator, and you can see this is the expected value of the x. Well, how you can do that? This is yi divided by xi over n. So this is the right answer. This is not the right answer. Why? Because this is applicable only, first of all, when x bar is my 0, but it is not given to you. Y bar is 0, again it is not given to you. Moreover, this applicable is only when it is a sigma square, but it is a sigma, so you have to firstly convert them. So this option is cancelled, this cancel, this cancel. So the right answer is only my third is the correct option. Look at the another one again, which is again similar to this, where xi's are the fixed covariants. Now you can see that these are the IID, epsilons, what is that? This is normal distribution, 0 and sigma square. Now you can see it is satisfied our previous requirement. Then you can find the value of beta 1, beta naught, and here. And some observation given, MLE of this. So fine. Firstly, we can find the estimator of beta cap. What is that? This is xi minus x bar, y minus y bar over here. Fine. So what is x bar? You can see 6 by 3 is a 2. What is the y bar? Sum of this. So it's a 6 plus 6 over 3. So 12, that is a 4. Now you can find this value. So 1 minus 2 is a minus 1, 1.9. Plus is a 2, is a 0 of something. Plus when you take as a 2, it's a 1. When you taken as a 4, it's a 2. Divided by x minus x bar whole square. So 1 plus 0 plus 1. So it is a 1.9 plus 2 by 2. So 3.9 divided by 2 is the estimator of the beta cap. Now you can find the estimator of the alpha cap, that is a y bar minus beta cap of x bar. You can see the same formula I have written here. Here is a beta naught is a constant value. In this case, alpha is my constant value. What is the y bar is 4. Beta cap is 3.9 over 2. X bar is my 2. So the answer is 0.1. Now you can check about that. The maximum likelihood estimator of alpha is my 0.1. Correct statement. Maximum likely estimator of beta by alpha. So what is that? Beta upon alpha is, this is 1.95 divided by 0.1. What is that? This is 119.5. This is also the right answer. Fine. Now the second is you have to find the estimator of alpha in terms of the least square, in terms of the BLUE, that is a blue. So now there is a simple remark for you. Remember this important tips for you. First tips: when variance of epsilon I is my finite, fine, then the least square estimate, it is also called as ordinary least square. It is also called as ordinary least square, OLE. Then the least square estimate of the minimum variance alpha is same as that of the MLE. Fine. Whenever variance of this alpha is finite and they are IID, they are epsilon i's are IID, then the minimum variance obtained by the OLE is same as that of the MLE. So we obtained the MLE is 0.1, so this option is also correct option. Although this is the question related to part C, why we consider? Because this is the question related to the linear regression and I consider the same here. Second remark, this is the BLUE, that is a blue, best linear unbiased estimator. What is the property of this? If expected value of the error is 0 and variance of epsilon I is my finite, fine, such that this epsilon I follows my normally distributed, then ordinary least estimate is equivalent to the blue estimator of parameters. So in this case, this is my alpha. So what is the OLE of alpha is 0.1. So it means blue parameter is also 0.1. So according to this, all are 4 are my correct answers of this problem. Remember this, your target is always to find the MLE. Once you find the MLE, if this condition satisfied, all are my equivalent. So that's why MLE of alpha all are my equivalent is the correct answer. So I hope you can simply learn the simple tricks. You can note down in your copy so that you can recall your GATE examinations as well. We will solve the part C question related to the statistics in our next lecture. Till then, you can simply scan and join my here for the various discussions. I hope you can simply like, share and comment my video. Best of luck students. Happy learning.